Hello, it's pre-calc time, and today is February 5th, so you'll be watching this either on the 5th, 6th, or 7th, and it's the weekend lesson. So that is 2-5-16. Before some old business, before we start the new, Emily, here's how far we got on our daily work. So I will show you that work. I'm not sure if you toted your book home or not. It's not something we normally do, so I'll show you the work. So, let me pull the book over here into the light, 65. Where are we? 65. You can see the answers there, so you can work toward them. 67. 68, 69, 70, and then we jumped over to a word problem, which was number 84. Alright. Okay, hopefully that's helpful. Hopefully that helps. Alright, so we are looking, that's how far we got after you left. Pretty much everyone was at the same spot, so excuse me. Picture of my grandkids. Oops, one of them's not showing there. It's kind of an old picture now. They all look so much older. Okay, let's look at what our lesson's about. That's the old business. Let's see. We're going to call this, we're talking about geometric sequences, and we're going to go to geometric series today, and we are going to sum up those series. So what we learned so far is we have taken the nth term. To find the nth term of a geometric series, it was a sub 1 r to the n minus 1. So that was the nth term, and today or tonight we're going to look at the sum of n terms, just like we did with the arithmetic series. So we're going to develop that formula. I'll come back and fill in that box with an important expression. So before I do that, let me take a little trip into the algebra. And just reminding you, because this will show up in the development right away, suppose I have an expression like this. 3 equals 5x plus 2y. And as you know, we're allowed to, say, subtract a value from both sides if it's the same value. So I can subtract an a from this side and subtract an a from that side. And I normally would write it 3 minus a equals 5x plus 2y minus a. So that's a subtraction property of equality. You may, if you have two things that are equal, which we had an equation, this side equals that, you may subtract from both sides. When you do that, you still have a statement that is equal. Now, I'm going to kind of ramp that up a little bit. And let's just say we have 3 equals 5x plus 2y. And we have another an equation. 8 equals 2x plus y. So, does it make sense to you that if I want to, I can subtract this equation from this one? I'm doing the same thing. I'm taking two things that are equal and subtracting them, one from one side, one from the other. It's just that this equals that. So I'm going to subtract this and subtract that. That's just as legit. So let me see how that looks. 3 minus 8, and I'm subtracting a 2x from a 5x, which is a 3x, and a y from a 2y, and it gives me a y. So this statement is just as true as the two before it. Alright, just keep that in mind when we look at that. Oh, I'm sorry, this is 2y minus y, so it's 1y. Now it's just as true. Alright, So let's look in more general a way to use that principle. We know that we have started out, we could get the sum of n terms that are in the geometric pattern by starting with the first term, adding the next term, which is a sub 1 times the common difference. And the next term, we multiply the common difference times this. We get that. And the common difference and the common difference keeps building until we get to the nth term, which I stated up there was a sub 1 times r to the n minus 1. And that n minus 1 shows up in the fact that in the second term r was used once, in the third term r was used twice, in the nth term r was used n minus 1. Alright, so we talked about that last night, or yesterday. I did problems with that in mind. We didn't get to those problems. Okay, so when you get to those problems, we will see that. I'm going to develop another thing we'll also use on Monday, and that is the sum of these. What we did, you're going to be using this a lot. And I think we did some on the board, that's right. We did a little bit on the board, but we didn't get to them in our seat work, but that's alright. We'll get there, I promise. Alright, so I'm going to develop the formula for the sum of n terms that are in a geometric series. Once I add those pluses, it's called a series. So, the way I'm going to develop it is start with this, and now I'm going to put another equation that is also true right under this one, and that equation will be obtained by multiplying the top equation by r. So every single expression, every single term on the left and the right will be multiplied by r. So when I do that, I get s sub n times r, and I get a sub 1 times r, and I get a sub 1 times r squared, and a sub 1. So just indicate here I'm multiplying everything by r. So this gives me that, that gives me this will give me r cubed. When I get to multiplying this times, I did these three. Now it's this times this. It'll give me a sub 1 r to the 4th. And what will it give me for the last term? So what will it be when I get r times a sub 1 r to the n minus 1? Well, when I multiply a sub 1, here's what I'm thinking about in my thoughts, my thought cloud. I have r times a sub 1 r to the n minus 1. So that's like r to the 1. So when I multiply it, I add these exponents. So what is 1 plus n minus 1? Alright, I can almost hear you say a sub 1 times r to the n, because the 1 and the minus 1 will add up to 0. So I'm going to put that, get that out of my thought cloud, and put it in the expression here. We will have something like a sub 1 r to the n minus 1 when I multiply it times the term right before this that I don't show in the dots, and then I'll have the one I just showed you, a sub 1 r to the n. Alright, I don't know if you can see what I'm going to do with this. See, I zoom in at part of it at a time so you can see it clearly. I am going to take, now that I've multiplied this whole thing by r, I'm going to subtract this equation, this whole thing, from this equation. So when I do that, which I am allowed to do algebraically, that is sound, I'm going to get s sub n on the left minus s sub n times r equals. But look, this a sub 1 minus nothing that matches that is just a sub 1. But this subtract that, this subtract that, And the fun begins. And then we're subtracting this from nothing. So we get a minus a sub 1 r to the n. So when I subtract this from nothing, I get negative a sub 1 r to the n. Alright, we're trying to find s sub n. So I see s sub n in two places. I really want it in one, so I'm going to take it and factor it out of this expression. So s sub n, when I remove it, factor it out. It's like removing a common factor. I get a 1 minus an r. You can always check that's right by multiplying, distributing the s sub n, see if it gets you back to where you started, which it does. And let's see what I can do over here to clean that up a little. We'll pull out an factor out of a sub 1. We don't have to do that, but it will make it look nice, be easier to use. So I factor out of a sub 1. I get that, and now I want s sub n, so I'm going to divide both things by that. Alrighty, how's that look for a formula? It's not as nice. Remember the arithmetic one? The sum of n terms was n over 2 times a sub 1 plus a sub n, so that was nice and sweet. This one isn't as sweet, but it's not that bad. Alright, I'll put it back in our magic box here. Anything that goes into the magic box is deposited into your long-term memory. So, I can visit you on your deathbed, and you will remember that. Alright, magic box. Hopefully I'm in glory land looking down when you are on your deathbed. Alright, so let's see what we can do with this. Let's do a problem. Alright, I'm going to turn this off and start part 2. Sorry about that, Morgan.